ago, and I specialized in automatization. So I made robotics and PLC programming on my own, and the teacher was always more going in the thematic of how it is known, digital twins.
Mm-hmm.
So I made my engineer degree on digital twins and the virtual machining, I would say. So it was like a project based on it's German company Machineering GmbH.
Okay.
They are doing like digital twins. They are fully involved in the topic, and I use the software in the beta versions to make one of the first virtual systems, and then I played the PLC program on the virtual machine, and it was the same program as the real machine that we had in the university, and it worked. So
Nice.
I made it. It was great. It was a great experience, and it was COVID, so it was also the good time because I could make everything from home, and I was
Yeah.
not linked to the university. And then I went back home, I would say, and find a job at a manufacturing company for tools. So Ceratizit, its specialty is like milling cutters, among others. So I have bright variety. And I was in the R&D for them for digital, further digital things like I was a lot involved in simulation because it was my background. It's really my background, the simulation stuff. So I made simulation of coolant. I made simulation of the process itself. I was also developing a new methodology process for the parts because it was a little bit inefficient. So I was also involved in visual metrology, and that's also a big topic where I was involved. I also was involved for sorting of recycled pieces. So the strategy was like we need to be, I would say, green, not green, but it's like the idea behind. So the Ceratizit bought back the inserts and tried to bring them in the powder. So at the base it's a powder, and you have the sintering process, and at the end you have the inserts for the milling cutters, and you can buy the inserts back and bring them back in the powder state. And for that you need to know which type of metal the inserts are made from. And I was involved, so I was also with X-ray undergoing research. How can we be efficient for the sorting of those kind of pieces? And
So
I
you've
always,
really done quite a bit
yeah,
all over the place with AI as well. So I guess that leads me to what are you hoping to get out of the course then?
yes, that was at Serra. So I'm not at Ceratizit anymore. And at Ceratizit, I was always working very, very close to the topic. Make it sense to implement an AI, or is it not adapted for the kind of data that we had? And I'm not in the capacity to say at which point is it interesting, at which moment, because I'm focused on simulation. That's my main point. And in simulation, you're doing stuff where you don't have any data. You try to find new ways to develop and to push your understanding. And with AI, I don't really understand if you can push or if it's based on data you already have, and you try to better understand your data. And that's my breaking point. Like, is AI even interesting, or is it just like using all data and saying, "Oh, we got new information"?
Right. Well, that is fascinating because we'll talk. Is it? I want to say it's week 3, but we start looking at optimization and reinforcement learning, and that's an area that I've dipped into a few different times. But the simulation piece of it is fascinating to me in whatever way, whether it's reinforcement learning or something else, because it's probably the best combination of you're getting enough of reality to make a digital copy of it, whether it's you call it a digital twin or it's a basic simulation. But then you're using additional information that you're getting to essentially create new data, new information, and you're getting answers from that. So like one area that we worked on was creating a digital twin for a tiny robot arm in a satellite. And we never got funding for it, so it's on my list of things to try and get funding for. But what we were working on is creating a simulation for this tiny robot arm that would be inside of a CubeSat. And it would be tied in with an AI model that would essentially see the health of the CubeSat, and you would set up the different components where if something went wrong with a component, it could pull it out and replace it with a backup of whatever component it was. And again, that's not how you do satellites, but it just as a proof of concept. But looking at seeing what we would need in order to create a realistic simulation of this. So the robot arm was fairly basic because you can, depending on which product it is, you can download that online. You could find the physical model of that. But being able to have kind of a microgravity situation where you have a CubeSat that might be tumbling around, you have quite high variations in temperature where it can get very hot or very cold, depending on if it's in the sunlight. You have radiation, which might have weird effects. So being able to simulate that well enough was quite the challenge. And we made it partway there and then decided to move on to something else. Mainly for funding, though. I think we could have made it further because there are different groups of either scientists, researchers, or companies that are working on those different elements. But really, if you can make it realistic enough, then you can move from simulating it to implementing AI, where you use something like reinforcement learning, which I equate that to teaching a dog a trick, where you can't just tell it what to do, but you can give it signals on what's beneficial, what's bad, and you can find its motivation, which is almost always food. And you can convince it to do all sorts of different things. But with this, you can set up reinforcement learning for this robotic arm to be able to, one, understand if something's wrong, where it's wrong, and then how to fix it, how to replace it. But using that simulated environment as a way to generate that new data and generate the model, train the model to where you could then put that on a real robot and send it into orbit and have it be able to perform the same way. But that balance between simulation and AI is extremely critical because you have to have a realistic enough simulation that whatever your agent is, whether it's a robot or a person or something else, can behave in the same way in the digital environment. So we'll definitely get into that next week. So have your questions ready and we can look at that. But I wanted to talk through, well, first off, do you guys have any questions about the first week and a half of the course? Barbara, I'm still looking at your paper, so I will give you feedback on that. No worries there.
That's okay. I think it was my fault because I wanted to do it as a PDF. I don't know, I just got overexcited with it. And then I was like, I want a diagram and I don't want it to be a PDF. And then it crashed. I don't know, it just didn't work.
Nothing would surprise me. I think PDF should be allowed, but let me check on that because it could be one of those weird things. And this is a new system we're using because the one for the last few times just was not great. I think it was meant to be more visual where you submit like a photo, like a JPEG or something. And so all the writing was in JPEG form and that was just a mess. But this should do PDFs. If not, I'll have some things to say to my team on what we're doing.
I'm pretty sure it said that it's allowed. I'm pretty sure it said that it was allowed. It's just for some reason it didn't like it.
Yeah.
But
and
yeah,
that
no,
certainly happens.
yeah. First week, great. I know that obviously, as we talked about last week, like in terms of what we currently do as a company, when nowhere near AI, but it was really interesting to look at data in a different way. And then again, sort of like trying to optimize those sort of processes and data analysis within Excel. And it's
Right.
great. And it's great. I think Python would be really great for that, even if it's not to build an AI system, but just to automate, yeah, sort of automate some of those processes would be great. It's just, yeah, trying to work your way around it.
Oh, right. What would be an example of one process you would like to automate? Maybe we'll play a little game.
So our estimating team has all the drawings that have been, drawn and laid out in a different system, sort of like AutoCAD, and it gives you a bill of materials.
Mm-hmm.
From that bill of materials, you can export the HTML code or whatever that has that bill of materials and different, basically all the data that is within that drawing. And from that, you can extract the bill of materials in a format where you can copy and paste in a different Excel spreadsheet that would give you all the prices. This was done manually initially. So from the bill of materials, you would just look at the drawing, have it open, and then type in each and one of the materials, and then do some calculations for the beams, for example, that you would use. I managed to use macros and then extract that data into a list of bill of materials and the quantities that you copy and paste. However, I know for sure that with Python, you can force open the HTML links one by one and then import that data and then end up with a list of, house type number 1 has this, it's going to cost that much. House type number 2 is going to cost that much. And then input that data automatically, where you just let it run for 30 minutes, let's say, and it does it all instead of you doing that manually. Does that make sense?
Absolutely makes sense. I've spent too many years doing the same sort of process improvement where it's you look and you say, oh, so your job is to just look at those numbers on that screen and then type them out on this screen and then just do that. Yeah, okay. And then working, like you said, with Excel to say, okay, how do we copy and paste and format it to where we can do different things? And then no one can tell me it's a bad idea macro, because I lived and breathed macros for a while and then got into doing the coding with whatever the programming language is, with the Microsoft Office macros.
VBA.
Something like that. For some reason, it'll come to me. It doesn't matter though, but it's that like quasi programming language that you can then do that.
Yeah.
That was before Python had taken off though. So I think you are correct that whatever could be done with macros and other things can be done better with Python. Now, Python is one of those massively powerful tools that you could be an expert in it in one area and have never touched another area. So it really is honestly the typical process of looking up similar problems that have been done before and looking at the code and using the code and then modifying it until you understand it and doing that. But you're exactly right in terms of the process improvement and the process streamlining. Now, what I would say, I think all of that is good and should absolutely be done. And as you said, with your company, being early on its AI journey where you're still working on that sort of process improvement, it's all kind of the spectrum that's really about process efficiency. Whether it's, oh my goodness, we just we installed Excel for the first time and it's amazing, to, hey, the AI takes care of it. All of that is a very respectful spectrum that, as long as it's like fitness, as long as you're working on yourself a little bit each day, then it's the right thing to do. But I love your idea of looking at how you can manipulate like the HTML files and pull data out of that and then do things with that. I think that's the right approach. One thing that you should also look at, if I can suggest, is think ahead and allow yourself to look at like the next year or two on what could be possible, knowing that you're here and you're not ready for it yet.
Yeah.
But looking at where you can take it can help inform some of the decisions you'll make today. And I'll give an example of this. I had a conversation 2 hours ago about this automotive factory that I'm just helping advise them on, but so I can give some of the high level details. But it was a very similar conversation to this. It was, how do we solve this problem now? But then what can we do with that in the future? So if you look at your drawings, and those drawings have bills of material embedded in them, so essentially it's extracting the bills of material, and then you have another system that shows the pricing, and you can do that. Now with this, so these are our customers who want you to then make something for them. So the bill of material is for you to buy and then kind of combine into what's on the drawing. Is that right?
So the bill of materials would be all the products that we currently have in stock. It's just how many need to go for this house type as opposed to the next house type.
Okay.
Typically, it's not just one house. It would be 10, let's say. And then you just do the quote for all of them, because obviously you want to be priced for all of them so you can send them all together. And then those would be in different job folders. And then obviously there's so much to be done in so many different areas. It's just, obviously, if I'm looking forward, we probably won't need people to make the drawings. We can just get the PDFs or whatever, the AutoCAD drawings, and then AI can just say, this is the floor layout that you need structurally, based on whatever calculations and the things that you already have. There's a lot.
Right.
If you're looking forward, it's just one step at a time, I guess.
Right. No, you're absolutely right. I think what you're doing now is exactly what you should be doing. But I see that you're already starting to play the what if game in a good way. And you also make a good point that you can look at the process upstream and downstream. So you can look upstream like you're doing and saying, well, why do we even need to make a drawing? Why isn't the drawing automated? So almost like you're like this 3 or 4 year old child who's throwing a tantrum. Why does it have to be this way? Is a great attitude to have. As long as you don't have the whiny voice with it, then you can say, well, why do we even need this? Why do we even need this system? Why do we need this go-betweens? And that can inspire that, because you could conceivably look at and this stems back to the conversation I was having a few hours ago, is how do we use AI for manufacturability? So how do I take something that I can look at either a picture or I can look at some basic data, and as long as I understand that, like if I look at an overall picture of, say, a floor or something, and I have some idea of the standards that I have to build it to, and I have some idea of the measurements, so I can see, the geometry, then you could conceivably build a tool, or probably take a tool that already exists and just modify it and say, okay, scan this area, give me the area. Also compare this to our different standards on what this would have to be in terms of the type of material, all the different things that make it work, either around the edges or additives in there or other things like that, and put that all together to where you can generate the drawing, but also the bill of material. And then looking downstream, you could look at, okay, if I'm doing this, and we're doing this for all of our quotes and other things, then I can put together this kind of grand bill of material that I might need, and I can start doing production planning and production forecasting. And I can start to look at, hey, if I'm doing this and this is going to take the next 2 or 3 months, then I can start to understand what we're going to need. And if I can do that, then I think I said, maybe it's on the first lecture, that AI is either like you're this omnipotent God who knows everything going on at once, or you can look in a crystal ball and predict the future. So if you can predict the future of what sort of things that you might need, then you can start to look at your manufacturing, or you can look at your supply chain and start seeing what you need to buy in bulk, or looking at your lead times and seeing which of your vendors are very accurate and which of them are going to be late probably, and you need to plan for that. But yeah, using all that data to automatically flow in those different systems to do that. But then, yeah, optimizing your entire factory. So the conversation I had today, it was with a company that takes raw metal and basically they machine different parts, very, very high precision parts for different customers. And the problem they faced was they're given some type of drawing, and they have to spend a massive amount of effort taking a drawing and looking at what will it take to make this thing. So they have to factor in what are the different geometries, how many sides do we have to cut, what angles do we have to cut, what holes do we have to drill, do we have to put in threads for the holes. And then on one side you have, here's what are different robots that cost different amounts to run and to operate, and the people with them can perform at different tolerances. And our customer has their own set of standards of multiple sets of tolerances that they have. So what they have to do today, and they're a pretty advanced company, they have to get their teams of engineers, their software engineers, to kind of decode what the 3D drawing has. They have to get their, I don't know if they're mechanical engineers or structural engineers, but they look at the material itself and its capabilities and what has to be done. They get their manufacturing engineers, and they have to, who are the experts at the robots and what the robots can do. They have to look at what can be done there. Then they get their operations manager saying, well, hey, if they want these many pieces done per month and we're going to go into business with them for a year, here's the impact that that's going to have on our entire operation, which is a smooth running machine. And now we're going to throw this order into it. So they have to do all of that, which takes, well, it depends on how much effort they put into it at once, but can take like a lot of hours of very high paid people. And then they give it to the customer. And at that point, the customer doesn't have to say, yes, let's do it. And in fact, the customer can say, thank you, take that to a competitor and say, hey, look, a lot of the work's been done. Do you want to give me like 10% better than what they offered? So it's this very unrewarding process that takes a massive amount of manual effort from very high paid people all working together. And so the question is, can AI be used to make this manufacturable? So there are different pieces to this. So there's software out there that you could go and buy today where you could give it a CAD drawing and tell it what material it is. And it would tell you with a specific brand and model of industrial robot with a specific type of cutting tool, it could give you kind of the instructions of what it would take to do that, which is good. It's a start. But if you have a factory that's already up and running, that has maybe some of those robots, but it has a lot of other robots, then that really doesn't solve your problem. It informs you. It's a nice advice, but it doesn't solve your problem, because your problem isn't how to know how to make that. It's how do I make this as fast and cheaply as possible with my factory, with the current orders that we're doing right now, with the orders that we're projecting we're going to have in the future. And I want to know the hard limits. So will this order cause me to have to go and purchase another robot, or hire 5 more people, or tell another customer that they're going to get their order later? That's the problem I'm trying to solve. So this other software can't do that, but it could be used maybe as part of a bigger system. So when we're looking at AI, that's the type of thing that we have to look at. But what that also means is you're breaking down AI into different pieces. So one of them is, yeah, we need to know what a robot can do to, what angles it can cut, what is it capable of doing? And then you need to put on top of that, what is the tolerance? How accurate can it get? And then you need to compare that with your customer and say, will this do the job? Then you need to look at, what you're capable of, how busy those robots are, and can you feasibly fit it in? You need to look at your raw material. Will this significantly change anything? So it really has to build on, but you can also do that one step at a time. So the first step is probably, how do we, using AI, be able to either look at it or examine the data behind the drawing and tell us what it can do. And then we have these data sources called tolerances and the capabilities of our individual robots and teams. We need to create that data. So right now that data is in the heads of these different teams. So the operation guys, they know. So you got to hope that they're not going to get a winning lottery ticket or get hit by a bus or both, because they have the knowledge.
Yes.
And what was helpful was the person I was speaking with said, this isn't about getting rid of those teams. This is about those people are so valuable. I could use them for 20 other things, and I don't get to because they're being used for this thing that doesn't even make us any money, but is a necessary step.
Yeah.
So whether it's precision machining type things or working with construction type projects and looking at how to pull your bill of material out of a drawing. One thing I find, so as you're working on this step right now in getting this bill of material, it's really about being able to look at the parallels of what problem you're trying to solve and then doing the research based on that. Because when I was in aerospace, one of the first things that I did was exactly what you're talking about, taking those bills of material and then grouping them together. For us, it was less about cost because they were government contracts because we were building rockets. And by that point, the contracts are what they were. There's only so many people who can make whatever part that you were looking at. And there was a very strict process for how to do that. So it was one of those rare cases in business where the money didn't really matter because it was kind of locked in, but the time mattered. The lead time mattered a great deal. And we had very little good data on that because it was always the people in purchasing, they knew who was going to be good with lead times, who was not. They had zero knowledge of the larger program itself. So they had this very specialized knowledge that was no value to anyone else because they couldn't look and say, oh, you're going to be late on that. I have no idea if that's a big deal or not. That could cost us 10 million in a lost delivery fee. I have no idea. So I'm not going to do anything with that information. So it took us several years to get all that data, capture it in a way that we could actually use it, and then start building up those bills of material. And with some of the rockets, the bill of material was 30,000 parts and took 2 years to build a single rocket. So it was just this detailed mess. And I'm sure with yours as well, once you have this bill of material and you get into an exploded bill of material where it's more hierarchical, it gets very complicated very fast.
I wouldn't say it gets complicated. I would say the process is straightforward. It's not very difficult. It's quite simple. The thing is, as you said, it takes a lot of time. It takes a lot of stress from people trying to look into a different format, be there with a calculator. It takes away the human error.
Mm-hmm.
It allows you to have more time to actually discuss with customers and organize the deliveries. But then again, this is what I'm working on right now. But I'm trying to look at it from, as you said, the omnipotent AI guru sort of thing. There's so many applications. We have issues, for example, where you pick up one of the products, and then you take on a forklift, you drive it around in the yard, and then you just drop it, and then boom, it just breaks. Obviously, there's a lot of investment, there's a lot of things to be considered, but you can automate that sort of delivery from the factory to the outside where the stock pieces are, and then have a machine or a robot that does that. Or in terms of production, a person needs to go into the factory and look and see where we are with production in order for us to know, oh, do we have capability to start a new bed, or yes or no?
Right.
There's so much that can be done. And as you said, it's not all just about AI, but it's all about trying to streamline some of those processes to the best that you can, and to make it more effective, and obviously save some time, save some money.
Right. No, absolutely. And I think with cases like that, where you don't even rely on data as much as experience, as you're starting this journey, looking at, so for example, the person whose job it is to go in and say, yes, we can start a job, yes or no. That to me is fascinating, because there's so many unknown knowledge. I mean, there's a fully trained neural network. It just happens to be a physical neural network in the person's brain. And so to kind of dissect that, and what I would do is I would walk alongside this person, and I would get annoying really quick, I'm sure. But I would say, okay, what are you seeing right now? What are you looking at? Essentially, what data are you taking in right now? What variables, how important are the different variables? And then what math are you doing in your head that you're not even aware of, because it's just second nature? So trying to find out the pieces to that equation, but then also those more subtle things, like what could go wrong here? What are some of the things making you nervous about saying yes or no right now? And then that gets into some of the risk or uncertainty, which for AI is always something that I found there's a hard line between your university and your research and other things, where, the AI worked and we were able to do this, this, and this. But if you were to put that into the field, into a real company, it might work exactly the same, but it wouldn't solve the problem, because you have this area of uncertainty that would then cause you to have a very strong opinion. So with the supply chain, so we built, and this pulls into your simulations, Lucas, as well. So we ended up taking all of these bills of material, and so it was a bill of material that might last 2 years. So it wasn't like your bill of material where you have a bunch of them, and it's a lot fewer of them, but they're a lot longer in term. So you could look at one for a while, and it would evolve over time as well as drawings change and that. So we took them all in and essentially created a simulation, and it ended up being quasi AI Monte Carlo simulation, where it just basically, it's the concept of the multiverse. It said, okay, based on what can happen, and what it would literally do is, I imagine this guy named Old Jim as the guy who is going to go into this warehouse and pull each part one at a time. And then you would roll these digital dice saying, well, this time it takes him this amount of time to get there. This time it takes him this amount of time to get there. And he would build that rocket 10,000 times, piece by piece. And then we would have what data we had on how long it took for each step, or how long it took to get each part from a supplier. And then we could build the uncertainty around it. So you might have the average time, which is what a lot of ERP and other type of systems use, is hey, on average, it takes this. But if you have a 10-step process and you're using just averages, then you're automatically wrong, because if something is quicker than normal, that's great. But if it's waiting on something else, then it doesn't matter. So it would simulate the entire process. And each time there was an uncertainty, he would roll these digital dice according to the distribution, and then we would find this. So at the end of it, you had a full idea of what it was going to take to build this rocket. and you had your best case, your worst case, your most likely, but then you could see exactly what that uncertainty was. And sometimes, especially early on when we didn't have a lot of great data because it was just in people's heads, or they just had never bothered to even track it because it is what it is and it doesn't affect my job, we would have like a variation of like 3 years. Like it could be as early as this or as late as 3 or 4 years from now. So that's not great. So, but what it did show us was those key moments where there was the most uncertainty. So we started focusing on those areas, and it helped the model to get more and more accurate. So we saw those key events that caused the most problems. But it's really that uncertainty. So if I was looking at the person saying, hey, we're ready to start a new job or not, based on what you're seeing, you know, capturing all the data, but really that uncertainty is the key thing. And then seeing how much risk do we want to put into this? You know, if we're wrong, is that going to ruin the whole thing? Or if we're wrong, we might be delayed somewhat. And that makes a big difference too. And you can program that into an AI model, depending on how risk averse you are on wanting to do something. I forget where we talk about it, but it's called a confusion matrix, basically looking at how do you want your AI to be wrong? Because it's rarely going to be 100% right. So I guess even just something extreme like I have an automated car, and if it thinks it sees something ahead, it's going to slow down and stop. Well, a regular AI model, maybe it's right 95% of the time. But what I'd rather do is instead of every 100 things it sees, it runs over, 5 of them. I would rather it err on the side of caution. I would rather have the error go way up where it says, hey, I thought I saw something, so I stopped and it wasn't there. I'm much happier with that error than the other way around when it says, I just ran over a kitten because I didn't think I saw anything. Nobody wants that at all. So another element of really applying AI in a real application is managing that risk accordingly.
Yeah.
But you can also do that without AI, which I'm sure you're looking at when you're just looking at process management and process improvement. You're going to make those decisions, even if that piece is a manual decision where you're treating your data as kind of this trusted advisor, where it's still Barbara making the decisions, but this data is saying, here's what I see, here's my recommendation, but you do what you think is best. And then that also allows your expertise and your kind of gut feel to help inform it, even if you can't put that into numbers.
Yeah. But still, even if you do that and you manage to, let's say, process that in a way that it's already, you have a collected data, further down the line, that can be transformed to an AI, and that allows me to focus on other things and then leave that behind. So exactly. I know from in terms of this course, I am behind in terms of that, but it's a really good way of looking how the data is managed and what data do I need for this process to be completely run independently instead of a person doing it. Yeah.
Absolutely. And I think that's definitely the right approach. And what I found more often than not is, as much as we'd like to just jump into AI projects, more often than not, the process goes, hey, I have this great idea. We can use AI to do this, solve whatever problem. We look at it for 2 minutes and realize we don't have the data we need to do this anyway. Or we realize, hey, this process is crap, and we should make it an efficient process before we use AI on it. And or we make this process more efficient. If we get this set and automated, then we don't need AI here, but we can use it a bit further down the line and actually do that. But yeah, that's, I think, looking at solving the problem of process improvement instead of how do I apply AI, where AI is one of many tools, and really the one that you want to use the least, because it takes so much effort. It can do a lot, but it takes a lot to do. But just looking at how do I pull this data out and how do I automate that is in a lot of ways more valuable overall, because then you can, when you're ready to get to AI, you've already solved that hard part and you're ready for it.
Yeah.
So I think you're definitely on the right track. And it's also always funny to see these like higher technology companies, and then you realize that their processes are just as manual and backwards as anyone else's.
I'm not going to comment.
I have plenty of things to say about certain parts of the aerospace industry where you're like, so we build things that go into space, right? Where do we do that? Because I don't feel like it's in this room where you're writing down numbers incorrectly and we're making all these errors. I don't think the innovation is happening in this room. It's got to be somewhere else. So yeah, but at least it's a universal problem and we all have to work on it in our own way.
Yeah.
So, well, that was fun. Any other comments before we wrap up? And hopefully you're getting something out of this as well.
Yeah. I've completed the second task, and you have the checkbox A2 where you have to say, yes, I've done the job. But I don't know, do I have to wait on the assess peers before I click, yes, I've done the job? Or because I can only make it once and it's unclear, I can show.
That's a good, let's
because I completed, but then you have the task 2, and then you have, yes, I've done. But if I say, yes, I've done, can I still make the assess peers? Or
let's try it, because again, this system is new to me, so I'm figuring out all the ways that this can fail. So let's try it. Okay. And then next week, let me know if you were able to assess your peers. Okay. And if not, we know that wasn't the right way to do that.
Okay, so I submit. Okay.
But yes, even week 1. So Barbara, you were definitely not the only one who had issues with yours. You're the only one who had that specific issue, but there were two or three others that had other completely unrelated, unique issues. So there weren't any trends that something major was happening, but there was just the normal noise of stuff is going to go weird. So as long as everyone's, it's the first week. By week 8 or 9 of the 6-week course, we'll have it figured out.
Great.
Yes.
That's how it usually goes.
Yeah, that's usually how it goes. And then we forget until next time. So we better write it down. So in terms of one other thing I wanted to talk about, so part of this is for the recording for the people watching later, but especially for the two of you. One thing I was going to start looking at was nailing down a date for the in-person conference that we would have on campus. So I was looking at what I guess would be week 7. So that's the 23rd through the 27th of June. Okay. So I don't know if there's a day that would work better for you guys. So I'm going to send out a note to the course to see who all is interested in coming. No one has to commit at this point, but is there a better day of the week that would work? Part of me thinks having it on Friday would be easiest for people's work schedules. At the same time, if you're going to travel and you can make it for work, then Thursday might be better because then you can use Friday to get back to your house. Any opinions either way?
23rd, week commencing the 23rd.
Yes.
Oh yeah, that's fine. I'm driving to Luxembourg on Saturday, so I can just come early if it's Thursday or Friday.
So if it's Thursday the 26th or Friday the 27th, either one is good.
Yeah.
Okay, well, that made my job easier. That's a definite use case where we can just pop it one of those days.
I can just drive the other way around up north, right? And then that's not a problem.
Very nice.
I'm already on another business trip for the 8th. Oh. I'm sorry.
No,
Okay.
no, it's definitely an optional thing, and it's one of those where I have no expectations, but even if a handful of people want to come and check out the hands-on research and hear from a few of my team on what they're working on, it's great. But we can also publish some of it so you can see it later as well. So no worries there.
I would have loved to come, but if it's 20, I have to see. But maybe I have another trip. So yeah.
Yeah,
Difficult.
no worries at all.
Mhm.
No worries at all. Okay, well, I'll send a note out to the course, and then we'll start nailing it down so people can make
Yeah.
plans and get it set. And then it'll be last time it was about a half a day, and it was definitely too short. So I was going to do just a full day on campus, host you guys, have lunch, and have some different sessions.
Yeah, that sounds great.
Awesome. All right. Well, you guys have a wonderful weekend. Yeah, definitely reach out if you run into any issues or anything.
Yeah.
Barbara, I'll get you your feedback this weekend.
Thank you.
And then we'll hit next week running hard, I guess.
Perfect.
Awesome.
Thank you. Have a lovely weekend.
All right. Thanks, you too. Take care.
Bye.
Okay,
Bye.